Okay, just a bit of a recap on what you need to know. So the normal distribution, that's kind of your natural thing, where you have a standard deviation and you have a mean, and we have the hot chips were normally distributed. Rectangular distribution is also known as a uniform distribution. Triangular could be like that, could be like that, or could be like that. Expectation algebra, expected value of x, expected value of y, and variation, all that sort of thing you need to know about. Let's just tick these off. Binomial, we remembered binomial. Bi meant two possible outcomes, success and failure. No meant the number of trials. Me meant me, myself, and I independent, so each trial was independent from the other. And the all meant all trials had the same probability, so constant probability. If you can regurgitate those conditions in context, so when you say there's two possible outcomes, you have to say what is success and what is failure. And when you say all trials have the same probability, you have to say what the probability is. And you say the number of trials and what that represents, and explain independence in a sentence. You then, if you get the calculation correct for achieved, you actually get merit for the explanation. Okay, the Poisson distribution. Remember, this is a cookie. Okay, so we had cookies in class, and the cookie is a counting thing. Discrete means counting. So sorry, that's not the cookie, that's the chocolate chip. So the chocolate chip was the discrete. The continuous was the actual cookie. So the cookie was area, but that can be time, or it could be length. So you normally have events that you count, which sometimes are rare, over a continuous interval. So that's one thing to remember by the cookie. No upper limit. So think that there's no upper limit. No known upper limit is a good way of thinking about it, that you don't actually know what the maximum number of chocolate chips is. Whereas with binomial, you know exactly the maximum because that would be the number of trials. The events have to occur randomly. Okay. They shouldn't occur exactly at the same time or exactly in the same place. So if a chocolate chippy is there, another chocolate chippy can't also be there. They can't take up that same space. Proportional, what that means, if I've got so and so many expected mean of half a cookie, then the expected mean of the whole cookie would be double. In time, it might be the expected, you might have a mean for 10 minutes, and then if you wanted to change it for a mean for 20 minutes, you simply double it. And so that's our Poisson. The next thing is reading from graph. So you're given a graph, and you might have to read values off it, or decide what sort of distribution it is, guess what the standard deviation and mean is, that kind of thing. Alrighty, let's have a look at the formula sheet. So I've tried to connect what we've done all the time with the formula sheet. This bit here, that's 3.13. We're currently doing 3.14, so that was also 3.13. It comes into it a little bit, but we don't need to worry about that for this test. So we have covered that. Yes, we have covered that. So that there is your rectangular. So it's important that you understand that that comes with the graph, where you've got an A there and a B there. Okay, so that's a rectangular one. Expectation algebra, the only fishhook there is knowing the difference between a scale factor and repeated identical distributions. That's for excellence people, there's videos on that. We have used this formula here of, oh, not that one, we actually didn't do the union, we did this one. The probability of A, given that B is true, is the probability of A intersection B over the probability of B. We did it in the context of normal distribution. So with the intersection, you had to find sort of the area where A and B are both true. Okay, and let's move on. Here, that is important for excellence type questions, where you might find the mean or the standard deviation when you're actually given the probability and you need to find the z value. To find the z value on your calculator, you simply go standard deviation is 1 and the mean is 0. Notice the mean being 0 there. You get your z value, you are given the x value, and you're given one of these and you find the other one. So you might need that. One, triangular distributions. Again, they've actually given you this time the A, B and C, and so you can just plug those in very nicely into that piecewise function. So you'll be using that, and the area of the triangle being half base times height, connecting that with this area of the whole triangle will be 1. So if you find particular area, then that would give you the probability of between that and that happening, because the area under the graph is the probability. Okay, binomial distribution. Remember this one here. So n is the number of trials. Okay. Pi is the probability of success in a trial. So the mean for the distribution is the number of trials times the mean, times the probability of success. And here we've got the standard deviation, so that's a really good formula to know about. This one here, again, you could use for excellence. So even though you can plug a lot into your calculator, sometimes you can't. This one seems to come up with excellence when you know the probability of x equaling 0 and you've got to solve for pi. And same with this one here. Okay. Here the mean is lambda, so lambda and the mean, same difference. Lambda is also our probability, and we're given that over a continuous thing, continuous time or space, and we change the time and space by changing lambda. Standard deviation is the square root of lambda, could come up. And again, when we've got the probability of x equaling to 0, lambda to the power of 0 is going to disappear, and lambda factorial is going to disappear, so I get e to the negative lambda. Okay, so if you're given this, you can find out lambda. Okay. Now I think the only other thing I need to show you there, perhaps, is what that means, just in case. So if we go back up, it actually means this. So NR is NCR. And you have a calculator button for that. And go back down here, get my calculator out. Okay. So that NX is actually NCR, and we're looking at when X is 0. So if we grab our calculator and we menu, execute, and we are options, and then we need to go to probability. Now notice here you've got the random number as well. So we are looking for when X is 0. So if I go 5C, 5C 0, I guarantee it'll be 1. If I went 9C 0, it's 1. If I want C 0, it's 1. So what I'm trying to say there is, just like what I was saying here, anything to the power of 0 is 1. That becomes 1, so that disappears if we've got the probability of x equaling 0. Anything to the power of 0 disappears, and if x is 0, then that's gone. So I end up with a value that you're given, whatever value that might be, equals 1 minus pi to the power of n. So if you've got the number of trials and you've got a probability, so if you know the probability of x equal to 0 is whatever, and you know the number of trials, you can actually solve for pi. Okay, so those both kind of work similarly. Okay, good luck.